to the absolute value equations, practice problems that we were given. All right, so these questions usually aren't so bad. The bad part is often just that when we're finished our pretty rudimentary algebra often, we have to end up checking our answers, and that can be kind of tedious sometimes. And we'll talk about a few different strategies for doing that. All right, I'm just going to label up here. These are absolute value equation solutions. All right, so we got question 1, which is absolute value of 3x plus 8, and that's the same thing as 5. And we're looking for a value of x that makes the left equal to the right. You might be able to puzzle your way through and think of a number off the top of your head, which is great. However, we're going to go through a systematic way to try and catch all of the solutions in case there are multiple. All right, so there are two possibilities if we have an absolute value symbol. The number on the inside could be positive, and it's hard to tell if it is or not because we don't know the identity of x. If x is, say, negative a trillion, then this whole number evaluates to some negative number. However, if x is a positive a trillion, it becomes a positive number. And as a result, we're not sure if these absolute value symbols are going to do nothing at all, which would be the case if it was positive, or if the number inside is negative. And the negative case, the absolute value symbols will turn that number positive, but in math language, what that really means is it's going to multiply the values on the inside by -1, and that's what it means to turn something positive. All right, so we have to split this into two possible cases because we're not sure which case exists here. We're going to imagine that these absolute value signs do nothing at all because the number inside is positive. And then we will solve that equation. We would also consider that it's a negative case where the number on the inside turns out to be a negative value, in which case the absolute value signs multiply the value on the inside, the 3x plus 8, by a negative number. Pardon me, by -1. To be specific, not just any negative number. All right. So at this stage, we're just going to do some pretty basic algebra. We're going to subtract 8 from both sides, and we'll get 3x is equal to -3, and then we're going to divide by 3. We'll get x is -1. And you might have looked at this and puzzled and maybe seen that -1 was one of the possible values for x. And then we've got -3x minus 8, because we distribute this -1 into a set of brackets, and that's equal to 5. We would add 8 to both sides, and that would give us -3x is 13. I should probably write a little bigger so that you guys can see on the video. And then we'll divide by -3, divide by -3. It cancels out, and we get x is also potentially -13 thirds. Okay. Now, we're not done until we test these values. We check. So we're going to check for each of these to make sure that we don't have, neither of these roots are what we call extraneous roots, which are numbers that algebra will reveal to be a solution for x, but when actually tested, they do not make the left-hand side equal to the right-hand side. So we'll test. We'll go with, we'll write the absolute value of 3 times -1, which is our answer for x, plus 8. Close that brace, and see if that's all equal to 5. So we'll evaluate here. We get -3 plus 8. Absolute value is equal to 5. And so then we get -3 plus 8. That's just 5. The absolute value of 5 is equal to 5. And that is true. This is a true statement. All right, we're also going to check here. We're going to make sure that this one gives us a solution for x. So I'll put -13 thirds in for x. So x is our absolute value of 3 times negative 13 thirds plus 8, and that's all equal to 5. Now I can see that these guys cancel when they multiply, so I really just get negative 13 plus 8 equal to 5, and negative 13 plus 8 is going to be the absolute value of negative 5, which is equal to 5. And that tells us that 5 is the same thing as 5. This is also true. So we get to make a conclusion that x equals negative 1 and negative 13 over 3. And there are our two solutions. All right. Now, unlike regular algebra, where this is an optional step, unfortunately, we have to be testing all of our possible roots. So we're going to see an example in the next case, in the next question, in which checking our roots reveals that one of them is an imposter. All right, so we're going to take a look at a question like that. All right. I'm going to just zoom in a little bit here because I think this is a little far away from the page. I can write a little bit smaller, which I'm more comfortable doing. And all right, then we'll look at question 2. All right, question 2 talks about the absolute value of a quarter of x, take away 2, and that's equal to x minus 3. So again, we have to consider the positive case and the negative case. The negative case. And okay, that's going to say that we've got a quarter of x. Take away 2, the absolute value signs do nothing at all because a number inside is positive. So when a number inside is positive, absolute value signs do nothing. And if the number inside this set of absolute value braces is negative, then it's going to take these numbers and multiply them by negative 1. All right, so let's see what we got here. We'll solve this one by, I think the good first step, if you have a fraction and it's an algebra question, is multiply both sides by that denominator. And that cancels out these denominators. We'll distribute this 4 to everything else. And I get x, I'll just go back to a normal color, x equal to, x take away 8, pardon me, equal to 4x minus 12. All right. And now we can do our normal algebra. I like to choose the side for x to be on such that x will be positive. So I'm going to subtract x from both sides. And I'm also going to add 12 so that the numbers without x's move to the other side. So these guys cancel and these guys cancel. We end up with 4 is equal to 3x. I'm going to divide by 3, the opposite of multiplying by 3, and find that x is 4/3. Potentially, we have to test that. It may not be. All right, and we'll repeat our process over here of algebra, but now we're going to have a negative version here. That's going to make it negative a quarter x plus 2 is equal to x minus 3. And I'm going to do the same thing. I'm going to multiply both sides of the equation by 4. And it's going to give us a value which will be negative x plus 8 equal to 4x minus 12. So I'll add x to both sides. And I will add 12 to both sides. And so I get 20 on the left is equal to 5x. And then divide both sides by 5. And we get x is equal to 4. All right. Now we're going to test to make sure that these answers work, that they are actual roots. They are solutions. So okay, let's check. So I'm going to multiply quarter by 4/3, my value for x. And I'll take 2 away from that value. And that should be equal to whatever 4/3 is when I take 3 away from it, allegedly. Now, I could run the numbers here, but I don't need to, because I know that whatever this is, the absolute value of it is going to be positive. This is going to be positive. But I also know that when I take away a number like 3 away from a very relatively small number like 4/3, it's going to give us a negative value. So I can already see this is not going to work. This 4/3 is an imposter. This is not a solution to this equation. It is an extraneous root. So I'm going to prove that to you. We'll multiply these guys together. The 4's cancel diagonally. That gives us a third. Minus, well, if I'm going to be subtracting 2, I can write 2. Just make this a little bigger. As put the denominator 3, which means I'll write as 6/3. That's equal to, I'll take my time here, 4/3 minus, I'll call that 9/3, same denominator. And so then I get an absolute value of 1 minus 6, or negative 5/3. That's going to equal 4 minus 9, negative 5/3. So I hope by now you're convinced that this is not going to give us a solution. You can see where I was going maybe if you didn't earlier. Absolute value of negative 5/3 is 5/3. That's equal to negative 5/3. This is false. So we take this information up here and we say this is an extraneous root. Now, you don't actually have to worry about the vocabulary extraneous, but that is technically the name we give one of these imposter roots that poses as a solution. However, when we actually test it, it does not actually solve the problem. All right. Well, let's see if the value 4 works.
Bye, Mr. Roberts.
Take care, Kira. Can you close the door, please?
Yeah.
Thank you. All right, so we'll plug in 4 for x, and so I get 1/4 times 4, take away 2. Absolute value of that is going to be equal to 4 take away 3, allegedly. All right, we're going to find out. So 1/4 of 4, well, that's easy. That's 1. Take away 2. Make my 1 look a little more 1-y so it doesn't look like an absolute value symbol. And it's going to be equal to 4 minus 3, which is 1. I'll make that one look more 1-y as well. All right, and then I get the absolute value of 1 minus 2 is negative 1, which is equal to 1. Is that true? Yeah, it is. 1 is 1. We're happy. So therefore, at the end of the day, we conclude that x is equal to 4, because when we tested, it actually gave us a true statement. But x is not equal to 4/3, because when tested, that actually gives us a false statement. I'm going to put a circle around here so that we don't think that that is the letter x is just an untrue statement. All right. Maybe that makes it a little bit more clear. All right. Let's move on to question 3. So question 3 says we've got absolute value 2x minus 6. And that's going to be equal to 2/3 of x plus 6. So as before, we'll consider a positive condition and a negative condition. And so the positive condition gives us negative 2x take away 6. That's equal to 2/3 x plus 6. And the negative condition says we'll take the negative version of negative 2x minus 6, which is positive 2x plus 6. And that will be equal to 2/3 of x plus 6. All right, so as before, when we have a denominator, it's nice to get rid of it by multiplying both sides by 3. So we'll do that. We'll multiply both sides by 3. So that gives us negative 6x minus 18. And that's equal to 2x plus 18. Interesting. Okay. Okay, so we'll get maybe all the x's on the right side so we can make them nice and positive. So we'll add 6x to both sides. And we'll take away 18. And if you solve for x on the left-hand side and you got a negative x, that's fine. It will give you the same answer either way. So I get negative 36, which is negative 18. Take away 18 on the right. And by right, I mean left. Oops. And I get 8x on the right. I'll divide by 8. And we find that x is the same thing as negative 36 over 8, which is the same thing as negative, what is that, 18 over 4, which actually simplifies even more to negative 9 halves. Okay, oops, 9 halves. Well, that's a kind of gross number, but at least it's not irrational. All right. So we'll see what we get here. We'll multiply a negative inside. We get positive 4x. Nope. Positive 2x. Positive 6. It's equal to 2/3 of x plus 6. Again, I'll multiply by the denominator. That helps to get rid of denominators. Instead of having to deal with fractions all the time, we get nice whole numbers. Except for maybe our x's, which may be fractions after all. In fact, it definitely will be in this case. Or will it? Oh, interesting. That's fun. Okay. So we'll maybe move all the x's to the left. We'll take negative 2x. And we'll move the negative 18 over here. And so on the left, we end up getting 4x. That's equal to 18 take away 18, which is 0. Don't panic, that's okay. 0 is a number, just like 36 was a number, or pardon me, negative 36 was a number. So there's nothing strange about getting 0. We'll just proceed as if it's another number, which it just is another number. So we'll divide by 4 on both sides. And we get x is equal to 0 divided into 4 equal parts, which is 0. Okay. So lastly, we have to test. So we're going to plug in negative 9 halves and see what happens. So I'm going to take the absolute value of negative 2 times negative 9 over 2. We'll take away 6. That's equal to 2/3 times negative 9 over 2 plus 6. All right, so I can see these 2's cancel. Maybe I'll use a different pen for that. So I get negative value of negative 9, which is 9. Take away 6. Absolute value is equal to... All right, so what we can do here? The 2's cancel, and I get a 3 canceling with the 9 to leave a 3. So I get negative 3 plus 6. So I get the absolute value of 3 is equal to negative 3 plus 6 is 3. So that tells me 3 is equal to 3. This is true. All right, so that means that one of our solutions is negative 9 halves. And we'll just test to see if 0 also works. This should be a nice, easy one. Test. Plugging in 0 is always the easiest thing to ever plug in. So negative 2 times 0 minus 6 is equal to 2/3 times 0 plus 6. All right, so what do we got here? Negative 2 zeros is, well, that's none. So actually I can just write as negative 6. It's equal to 2/3 of 0, which, again, doesn't leave you with much. It leaves you with 0. 0 plus 6 is 6. So I get the absolute value of negative 6, which is 6, is equal to 6. This is also true. So we get to conclude that x equals negative 9 halves and 0. All right, so moving right along, let's move on to question 4 here. So with question 4, we have a quadratic equation, and we're going to see how that works out. Maybe it'll give us more solutions than 1 or 2. It might give us a maximum, I believe, of 4, but I need to think about that. This one will. Well, I guess there's a potential for there to be even more. It could be infinity. All right, so let's write this out. Plus 6x plus 4. Absolute value of it is equal to negative a half of x plus 2. All right. So we got two situations happening here. We could have a positive version and we could have a negative version. So we'll take the positive version, nice and simple. I think I'm going to start moving a little quicker. And I'll save the explanation of algebra steps for when we have to deal with this quadratic. Because chances are, if you're looking at this part of the video, it's because you weren't sure what to do when we got to a quadratic. Not because you're confused about taking up, say, a positive and negative version of things. All right, or the basic algebra. So I'm going to multiply both sides by 2. Get rid of this 2. And we get 2x squared plus 12x plus 8 is equal to negative x plus 4. Now we have nice integer numbers to deal with. Now, we have to recognize we have two different powers of x. This means that we can't isolate x. You could actually technically isolate x using completing the square, but nobody likes completing the square, including me. So we're just going to solve by getting all the terms over to the left-hand side and 0 on the right. All right, so we'll add x and take away 4. And we'll add x and we'll take away 4, and we get 2x squared plus 13x plus 4 equal to 0. All right. Now we have two methods of approaching. We could try to factor this. I'm going to see. Did I do everything right there? 13. I think I did. Okay. Just double checking to make sure I didn't screw anything up with this step. All right. So I like to use my discriminant here. I like to just check and see if my discriminant is a perfect square. If it is, that means I can factor this. I might go through the process of factoring, because I personally find factoring a little easier than using quadratic formula. So I got b squared, which is 13 squared, which is 169. I take away 4 times 2, which is 8 times 4. So 169 take away 16 times 2 is 32. All right, so that is 137. Not only is that not a perfect square, I have a feeling that might even be a prime number. What? So because it's not a nice number, that means we're going to have to use the quadratic formula. So we're going to have to say, okay, I'll take the negative version of b, which is 13. And a square root. I actually just found the discriminant, the inside, so I'm just going to put that straight in here as 137. And then divided by 2 times 2, which is 4. This is a gross situation. I don't like it. So is there even a number that can multiply into a number with 7? Yeah, okay, 9 can. This might be some number of 19s, maybe. I'm not sure if this is prime, but I know that 9 is a perfect square, so we'll just check. 137 divided by 9. 9 doesn't go in. Am I kind of out of ideas? 137 divided by 13.
Please excuse this interruption. Could Ty please come up to the 5th floor? Ty, won't you come to the 5th floor, please? Thank you.
All right. That doesn't simplify it. This is gross. Is gross. All right, now before I finish, I'm going to actually write, I think, out the decimal approximation. So it's going to give us two answers. We'll have negative 13 plus root 137, negative 13 plus root 137, and I'll divide that by 4. So negative 13 plus root 137 divided by 4, that all equals negative 0.3238 dot dot dot. And x also equals negative 13 minus root 137 over 4, which is equal to negative 13 minus root 137 divided by 4. I get negative 6.176 dot dot dot. Okay. So we are going to test that, but we're going to use calculators to do it because it sucks. All right, moving on. We've got a negative version here. We're going to multiply negative 1, and so we're going to go through this quickly. Minus 6x minus 4 is equal to negative a half of x plus 2. I'm going to multiply both sides by 2 and get negative 2x squared minus 12x minus 8 is equal to negative x plus 4. I'm going to get everything on the right-hand side because I like my x squared term to be positive. So I'm going to add 2x squared, add 12x, add 8, add 12x here, add 8 here, and add 2x squared. It's going to give us 0 on the left and 2x squared plus 11x plus 12. And I can already see that that factors because I can see two numbers that add to 11 and multiply to 2 12s, which is 24. And those magical numbers are 8 and 3 and 8 and 3. So I'm going to factor that. 2x squared plus 8x plus 3x plus 12. So that gives us 2x and x plus 4 plus 3, x plus 4. And then we get 0 is x plus 4 times 2x minus 3. So our two possible solutions are x equals negative 4 or 3/2. Okay, so we're going to test all of these values. Okay. Now I'm going to do this in a calculator. I'll list first x equals negative 0.32. I'm going to call it 0.324. Alright, so we're going to say clear 0.324 squared plus 6 times, a little bit of glare there. There we go. Plus 6 times 0.324 plus 4 equals 6.04089. Let me write that down. So this tells us that absolute value is 6.048 dot 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 equals negative 0.5, which is a half, times 0.324 plus 2. That's going to give us 1.838. That's weird. Did we do something wrong here? Yeah, I did something wrong here. I didn't put a negative version in. I was using a positive number. Negative. So I'm going to go back. Sorry. Square. Negative 0.328 squared plus 6 times negative 0.324, not 0.328. 4. Plus 4. It's going to give us 2.16. Absolute value of 2.16 dot dot dot. Is that equal to negative a half times negative 0.324 plus 2. Oh my. 2.162. Okay, this is true. Actually, we do end up getting the same answer when we plug in a decimal approximation for this root. So this gives us a true fact. So we'll also test our value for x equals negative 6.168 and see what that gives us. So I'm going to use a calculator again here. So negative 6.18 squared. Oops, that's only going to square the negative 6.18. So open the bracket. Negative 6.18 close bracket squared plus 6 times negative 6.18 plus 4 gives us, okay. I was expecting a negative number. I can see why it isn't a negative number now that I do. But that was my intuition. Okay, I guess my intuition was wrong. Alright, so I'll write that down. That tells me that the absolute value of 5.11 ... should be equal to, I'll just try here. So we got negative 1/2. Just so we're clear, I'm plugging it into the original equation here. Times, what do we got? Negative 6.18 plus 2. Oh, okay. And I get like 5.09. Now, that's actually pretty close. Something tells me that I want a little bit more precision now. I don't know why that gives me. Okay, so I'm actually going to just double check that. I'm going to use another decimal this time. So, all right, so I'm going to square negative. I'm going to use this decimal. 6.176. Let's see if we get even closer. 6.176. Close bracket, squared. There we go. Plus 6 times negative 6.176 plus 4, 5 point. Okay, that gives us a little bit more closer. 5.0869. ... Is that equal to? This one here, we're just going to test. Is that equal to, if I multiply negative 1/2 times negative 6.176 and then add 2 to it, I get 5.088. Now that's looking pretty good. So I'm actually going to say that these two are equal. This is also true, I think. Now I need to test more decimals, and this is an irrational number, so there's no limit to how much you can test. Like how many decimal places. But I think after 3 decimal places with this one, I'm satisfied. These numbers got closer together when I used more precision. And so as a result, I'm going to say this is a true statement. I'll check. Test the value negative 4. Alright, that's nice and easy. So I get negative 4 squared plus 6 times negative 4 plus 4. Is that equal to negative 1/2 times negative 4 plus 2? Question mark. So is that the absolute value of 16 minus 24 plus 4? Is that equal to the value of 2 plus 2? Half of 4 is 2. Negatives cancel. So let's just see here. 16 and 4 are 20. 20 minus 24 is negative 4. That's equal to 4. That's looking good too. So we got another solution, looks like. All right, last test. We'll do 3/2. Absolute value of 3 halves squared plus 6 times 3 halves plus 4. Is that equal to negative a half times 3 halves plus 2? This is gross. Alright, so let's see here. What do we have? 9 quarters. That becomes 3, so we get plus 9 plus 4, which is plus 11. Is that equal to... Weird. What am I doing wrong? I guess, alright, we'll just see. Trust the math. I'll just trust the math. 3 halves 6 is 9. Plus 4 is not 9. 3 halves, so 9 plus 4 is 13. Okay. So whatever happens here, I can already start to see this is not going to be true. This is false. So therefore, x equals negative 4, which is the one that we tested was true, equals negative 13 minus root 137 over 4, because we tested it here. And x equals negative 13 plus root 137 all over 4. All right, but not this guy here. But I feel like something is wrong here. Like I screwed something up. I can't see what it is. But I guess that's the way life goes, right? I could try it again, but it's a late day and I want to make it through this video because I'd like to record some others for other students. So let's, what are you? Okay. Last question. Question 5. And I think to save paper, I'll do question 5 right on here. You know what my intuition tells me? I'm not going to have enough space, so I'm just going to use a whole piece of paper after. Alright, so question 5. We'll go through this quick. Maybe. We'll find out. Depends how gross it gets. Alright, so we'll have the positive case, which is 2x squared plus 5x minus 4 is equal to negative x plus 4, and we have the negative case, which is saying that we have a negative 2x squared minus 5x plus 4 is equal to negative x plus 4. I skipped a step there. I hope you can see what I did. I just changed the symbols for all of these because that's what multiplying by negative 1 is or does. Alright, I like to keep my x squared term positive, so I'll move everything to the right. So I get 2x squared plus 6x minus 8 equals 0. And again, same thing, also I'll move everything to the right this time. So we'll get 0 is equal to 2x squared, 5x, add 5x, add 5x, so we get plus 4x. Take away 4, take away 4. Oh, interesting, we got 0. That's nice. All right, so my first instinct here is to divide everything by 2, because I can see multiples of 2 sitting there. So that gives us x squared plus 3x minus 4. If you didn't see that they were all multiples of 2, that's fine. You can still proceed with these as your a's, b's, and c's for either the quadratic formula or for factoring. But when I can see something that can be simplified, I try to do it. All right. So I can see this can be factored. So it becomes x plus 4, x minus 1. That's equal to 0. So our x values are potentially negative 4 and 1. And here I can, well, first I can divide by 2, both sides. So that gives us 0 is equal to x squared plus 2x. And I still should factor. But factoring in this case means factor out an x. and I get x plus 2 left over. This leaves us with two possible solutions. X is 0, or x is negative 2. Okay, so now we have 4 different values to test. So let's test x equals 1. So back into the original equation we go, which is up here. So I'm going to say 2 times, I'm just going to write it as 2 plus 5 minus 4 is equal to negative 1 plus 4. Let's just find out if that's true. 7 take away 4 is 3. Absolute value of 3 is equal to 3. So 3 equals 3. True. So that means x did equal 1 after all. And we'll test x equals negative 4 next. So that's going to be a little bit uglier. Absolute value of 2 times negative 4 squared plus 5 times negative 4 minus 4 equal to negative 4 plus 4. Let's find out if that's true. Absolute value of 2 times 16 minus 20 minus 4 is equal to 4 plus 4, maybe? Looks good, actually. I can get a good feeling about this. 32 minus 24. Absolute value is equal to 8. And I can see we have the absolute value of 8 is equal to 8, or 8 is 8, which is again true. So we'll move on and we'll test these guys over here. X equals 0. This is going to be nice and simple, I think. So I punch in 0 for everything, and that actually just gives us absolute value of negative 4 is equal to positive 4, or 4 equals 4, which is true. And lastly, we'll test x equals negative 2. So we got absolute value of 2 times negative 2 squared. What's the rest of this thing? Plus 5 times negative 2 minus 4. That's all equal to negative version of negative 2 plus 4. So let's find out if that's true. Absolute value of 2 times 4 minus 10 minus 4. Is that equal to 2 plus 4? Let's find out. 8, take away 10, take away 4. Is that equal to 6? 8 take away 10 is negative 2, take away 4 is negative 6. And so 6 equals 6. This is also true. Okay, so there we get to make a conclusion. Therefore, x equals negative 4, 1, 0, and negative 2. Those are all the possible values for x.